Bismillah Rahman Rahim. Dear students, now we will be looking at the third option of EOQ plans. If you can remember, we have already discussed the first plan, which was actually the separate EOQ model. Then afterward, we actually checked the same data of that organization for the plan in which it was a combined production. Now we would be looking at the tailored production. In tailored production EOQ, we will be producing some combinations of different products. If you can remember, we had taken the example of three types of computers. So what were those computers? These were Light Pro, Med Pro, and Heave Pro. Now, first of all, we will be discussing the algorithmic steps that how would you implement the tailored aggregation model. And in this tailored aggregation, we need to follow 5 steps. I will be going through these steps first of all, then we will look at the example that will actually cover this topic and for the better understanding. So the step 1 would be to identify the most frequently ordered product, assuming each product is ordered independently. So what we would be going through, we will be finding the N bar, I would say. That would be based on the total fixed cost. When I say total fixed cost, that means your transportation cost would be a part of it. If you recall, we are actually looking at these 3 plans from the perspective that if you include your transportation cost as the part of total EOQ, then how would you achieve your economies of scale? So here, the first step would be to find N. N was, if you can recall the general formula for N, it was D over Q, R over Q, you can say, the demand over the quantity produced. And the specific form would look like as it is in the given in the slide. So N bar would be the under root of KCI, which is actually the holding factor, into the demand over 2 into S plus SI. Here S would be the ordering cost or the production cost, plus the small s would actually represent the transportation cost. Then step 2, for all products, that means what you need to produce or in combination, evaluate the ordering frequency. That would be NI double bar. Now, what that actually represent? That would be representing the ordering frequency, which would be the under root of KCI RI over 2SI. If you can see, we have actually excluded the transportation cost. So what will happen? In the first step, we have find the ordering frequency when transportation cost is the part of every product. In the second step, when we have gone through the first step, we would have find out, let's say, this specific model would be produced, let's say, 10 times a year. And the other model would be produced like 7 times a year, and the third model would be produced like 5 times a year. Now, what will happen? The highest frequency, that is 10, for instance, in this case, we will take that and we will evaluate the other models which were like 7 times a year and 5 times a year, obviously which were lesser than the highest frequency. We will evaluate the second step for those models. And now we will not include the transportation cost. Why? The logic is simple. You have included the total transportation cost for the first model. जो एक मॉडल जिसके लिए highest frequency आई है, ट्रांसपोर्टेशन कॉस्ट के साथ आपने allocate कर दिया है total transportation cost उसे. So now you need to exclude it from the other models in order to know their right frequency or the correct frequency. Then come to step 3. Step 3 is actually a kind of an index, which is represented by MI. It is to evaluate the frequency of product relative to the most frequently ordered product. जिसकी frequency सबसे ज़्यादा है, जैसे in our case it is like 10. उसके against आपने एक ratio find करनी है. That would be N bar over N double bar. वो दोनों frequencies ऑर्डर फ्रीक्वेंसीज जो हमने स्टेप 1 और स्टेप 2 में एवेल्युएट की हैं, वी विल एक्चुअली गो थ्रू दैट वन एंड वी विल कॉल इट MI, उसको MI का नाम दे दें. Then step 4 would be to recalculate the ordering frequency of the most frequently ordered product to be N. आपने recalculate किया है, जिसकी फ्रीक्वेंसी मेरे पास सबसे ज्यादा थी उसको थोड़ा सा एक्यूरेट किया है इसके अंदर. In some textbooks, step 4 would not be the part of this algorithmic. They prefer to stop at step 3, but we will be going through this step as it is recommended in most of the textbooks. Then step 5. The step 5 would be to evaluate the ordering frequency of Ni, which is N over Mi, and the total cost of such an ordering policy. So here in step 5, the total cost would be evaluated. If you can recall it, that would be the ordering frequency N into S. The first part would actually, in this equation, which will actually represent the ordering cost plus the summation or sum of NISI, that is the cost, the transportation cost for all the products, plus the sum of Ri over 2N into Kc, that is actually the total holding cost factor here. So after evaluating these 5 steps, intuitively we can actually say that tailored aggregation would actually give you a lesser cost if your transportation cost is significantly higher. अब tailored aggregation में है क्या कि all 3 models would be produced in combination. Sometimes one model would be produced as a separate one and it would be feasible, as well as 2 models could be produced in aggregation, and sometimes you will be producing the 3 models in aggregation. Now what is the importance of it? क्या importance हो सकती है? Importance ये है, ये ज़्यादा flexible है in reality to implement. Let's say मेरे पास एक मॉडल कंप्यूटर का मौजूद है लाइट प्रो, और उसकी डिमांड इन दी मंथ 9th मंथ आनी है. सो जब आप सेपरेट प्रोडक्शन कर रहे हैं तब ऑब्वियसली आपकी कॉस्ट कुछ हायर है, इंट्यूशन इज सच दैट, और आपको हर मंथ में आप उसे प्रोड्यूस कर रहे हैं. जब कॉम्बिनेशन, जब आप उसको एग्रीगेशन में प्रोड्यूस कर रहे हैं, सिर्फ एग्रीगेशन में, तो यू आर प्रोड्यूसिंग इट एवरी मंथ, तो दैट मीन्स यू नीड टू होल्ड इट. वो होल्डिंग कॉस्ट ऑब्वियसली उसका पार्ट थी. तो द इंट्यूशन इज here in combination you will produce it when it is required. If it is not required in the first 7 or 8 months, you will not produce it. So the combinations are flexible. कि अगर मुझसे ये कहा जाए कि in a year, let's say there are 10 times you need to go for production and Light Pro would be a part of, let's say, after every 5 production runs. That means in 10 times कितनी मरतबा आपके पास वो Light Pro बन रहा है, वो मॉडल कंप्यूटर का, that is only 2 times. So that means I am flexible enough कि मैं उस कॉम्बिनेशन को कहीं पर भी फिट इन कर लूं. वो 9/10 भी हो सकता है, वो 1st 2nd भी हो सकता है, डिपेंडिंग अपॉन द डिमांड विच वुड बी ओरिजिनेटेड बेस्ड ऑन योर फोरकास्ट. ऑब्वियसली EOQ, इफ यू कैन रिकॉल, इट वुड बी बेस्ड ऑन द फोरकास्ट, या आपकी फोरकास्ट पर बेस करता है. तो यू कैन एक्चुअली फिट इन दोज कॉम्बिनेशंस वेयर एंड व्हेन दे आर रिक्वायर्ड. तो तब आप उस मॉडल को प्रोड्यूस कर रहे हैं जब उसकी फोरकास्ट अवेलेबल है. ये नहीं है कि आप उसे पहले ही थोड़ी थोड़ी क्वांटिटी में प्रोड्यूस करना शुरू कर देंगे और लेट्स से 7th और 8th मंथ में जब उसकी डिमांड आई तो आपने तब उसे दिया. ऑब्वियसली इंट्यूटिवली द कॉस्ट, होल्डिंग कॉस्ट वुड बी हायर, जो कि, सो व्हाट वी वुड बी डूइंग हियर, वी विल बी टेकिंग एन एग्जांपल एंड we will actually implement these algorithmic steps for it.